Good afternoon, students. Good afternoon. Good afternoon, Vasiki. Good afternoon, Raja. Good afternoon, Arun. Good afternoon. So, welcome to the NEET free coaching class conducted by the Stella Maris Medical Foundation. We'll wait for other students to join with us. So, if you have any queries to how to join in this free coaching class means, just WhatsApp this number. They will tell the details about the procedure to join in this class. Okay, join in this free coaching class. Okay, ma. Okay, have you understood? Okay, Vasugi. Just WhatsApp to this number. Okay, WhatsApp to this number. They will tell you the procedure to join in this free coaching class. Okay, for English medium only. Okay. Today is the class for English medium. For Tamil medium we have already completed for electrostatics. Okay, so today this class is for English medium students. Okay, ma. So today we are going to see chapter electrostatics. So this is the chapter from 12th standard, first chapter. Okay, so if you are studying from state board means it is the unit 1 electrostatics, in the name of electrostatics. Okay, if you are going to get the reference from CBSE means it will contains 2 chapters. The first chapter is electric charges and fields, and the second chapter electrostatic potential and capacitance. Okay, so for this chapter, if you are going to take the reference from NCERT book means, that means CBSE book means, you have to study both these 2 chapters from the CBSE book. Okay, have you understood? அவங்க ரெஸ்பான்ஸ் பண்ணுவாங்களா சார் கமெண்ட்ல? ஓகே. Good evening, Varshini. No, Vasuki, this is for English medium students. Okay, for Tamil medium you can use that page. Okay, that Facebook page you have already attended the class, no? So you have used that page for Tamil medium. So this class is for the English medium. Okay, good afternoon, Anand. Okay, Arun Kumar. Okay, Anand. Okay, shall we start the class? So this is the chapter from our 12th standard, first volume, first chapter. Okay, so if you are referencing the CBSE book means you have to learn these 2 chapters to complete this electrostatics. Okay, So first we will see some basic idea about electrostatics. Okay, so electrostatics, the name itself represents that static. What is the meaning of static? What is the meaning of static? That means anything does not move or change with time. Okay, so static means anything does not move, any object or any particle which does not move, it will be stable in the position. Okay, so static means anything does not move or change with time, with respect to time, that is called as the static. Okay, so in electrostatics it deals with the study of particles, study of forces, fields and potentials, about the static charges. Okay, so we know that static is nothing but anything does not move or it can't change, it can change with the time, with respect to time. Okay, so the electrostatics is nothing but, in this chapter we are going to study about the forces of the two particles which is in static. Okay, the forces between the two particles which is in static, and also the field, electric field between the particles, and also the potentials between the particles which is in static. Okay, the particles which is in static. Did you understand? If you have any doubt, tell me in the comment. Okay, I will respond. Okay, ma'am? If you have any doubt or any questions, means ask me in the comment, I will respond. Did you understand? So if S means, just put the comment S. Shall we move on to the next one? Okay, sir. Okay, sir. Okay. Okay, sir. Okay, sir. Okay, sir. Okay. Yes, okay, Satya. Srinivasan, okay. Okay, Tamil. Okay, Mohammed, okay. So we will move on to the essay. Okay, okay, Raga. Okay, Raga Kirtana. And also, we know that if we take the plastic, Ravi, this is for English medium class. Okay, Ravi? Ravi Sumadi, this is English medium NEET class. Tamil medium will conducted as usual Facebook page. Okay, okay, Ravi Sumadi. Good afternoon. Good afternoon, Dinesh. Good evening, Dhanasegar. Good evening. So if you have any doubt, means ask me in the comment. Okay. Good afternoon, Dinesh. Good evening, Sumesh. Good evening. So we will see one example for the basics of this electrostatic, to understand this basics of electrostatics. Okay, so we all have used this example in our childhood days itself. Okay, so if we take the plastic comb and if we rub that comb in our head, after that what will happen, that comb will attract the light objects. Correct? Have you all experienced, have you all did these experiments in your childhood days? So if you are rub that comb in our head, after that what will happen, it will attract the lighter objects. correct? The lighter objects is nothing but a paper or a straw or a pith balls, correct? So if we have all are experienced this example, correct? So if you have so why that plastic comb is attracting that light objects? Do you know the reason for that? Before rub in our head, that plastic comb does not attract anything, but after rubbing in our head it will attract. What is the reason for that? Do you know that? If you know, or if you want to tell me the answer, means tell me in that comment box. Okay, I will tell, because initially the charges will be neutral in that comb. Okay, so initially before rubbing in our head, the charges distributed in that comb will be the neutral in the sense there will be the equal number of positive charges and the equal number of negative charges. For example, if that comb is containing 50 positive charges means likewise it will have the 50 negative charges. Okay, so that before we rub in our head, that comb will not attract the light objects like paper, straw and pith balls. After that, what will happen? It will gain some charges from rubbing in our head. Okay, so every objects in the universe will have the charges. The charges are equally distributed in that object. Okay, so that it cannot attract anything, or we can't get shock from that. Okay, so we know that the plastic comb also having the charges, but we can't get shock from that. Why? Because the charges are equally distributed. Okay, the charges are equally distributed in all the objects. Okay, so equally distributed in the sense positive and negative charges are equal. Okay, so if it is for example, if it is the positive charge is 35, means the negative charge is also 35 will be present here. Okay, so after we rub that object with any other object, it will gain some charge from that object. Okay, so that only it can attract that paper. Okay, so for example, consider if it is the comb. So initially what will happen? There is the presence of positive and negative charge inside this comb. Okay, so initially there will be the positive and negative charges are present in this comb. Okay, so the net charge will be the 0. The net charge will be the 0 initially. The net charge is nothing but the positive and the total charge which is present. Net charge is nothing but the total charge which is present in this comb. Okay, so the total charge in the sense the total number of positive charges and negative charge. Okay, so after when we rub this comb in our hair, what happened? That hair will be the external medium to this comb. Okay, so it will gain some charge from that external medium, which means hair. Okay, so it will gain some external charge from our hair. Okay, so that only after the rubbing in our hair, this comb will attract the lighter objects. So this concept is coming from the electrostatics only. Okay, so this concept is coming from the electrostatics. Okay, after we rub, what will happen? The charges will, the comb is gaining some charge. Okay, it may be the positive or it may be the negative. We don't know how much charge it's gaining from this external source. We don't know. We will see in the next upcoming slides. Okay, so initially we don't know how much charge is gaining from this external source. Okay, so initially there will be the neutral charge is present here, after we give an external source, this comb will gain some extra charges. Okay, it may be the positive or negative, so that comb is attracting the lighter objects. Okay, have you all understood, or do you have any doubt? If you have any doubt, tell me in the comment. If you have any doubt, tell me in the comment, otherwise we will move on to the next one. Okay, shall we move on to the next one? It may be the positive or negative charge. Okay, Mohammed. Okay, it may be the positive means it may be the proton, or negative means it may be the electron will gain by that comb. Okay, we will see which charge is increasing by using the formula in the upcoming slides. Okay, Mohammed, did you understand now? Okay, so we will see the some basic properties of charges. Okay, so the first property is scalar quantity. Okay, so the charge is the scalar quantity. Okay, okay, Mohammed, and it is the transferable one. It can be transferred from one medium to another medium. Okay, and also the important point, it is conserved. Charge is conserved. Okay, so which means constant. The charge is conserved. And the last one is quantization of charge. Quantization of charge. Okay, so the first one is the basic properties of charges are, the first one is it is having the scalar quantity. It is the scalar quantity and it is the transferable one. It can be travel from one medium to another medium or one surface to another surface by applying, when we apply some external force. We will study these in our upcoming topics detailedly. Okay, and also it is the conserved. Okay, so the charges are conserved. Okay, sir, video play agave matte varuda sir. லோடிங் ஆகிட்டே இருந்துச்சு. ஆமாம் சார். ஓகே சார். Okay, so the last, it is the conserved, the conservation of charge. Okay, so the fourth one is quantization of charge. It is called as the integral multiple of fundamental charge. So the integral multiple of fundamental charge. Okay, so I have already told in this previous slide, we don't know how much charge is gaining by this object. Okay, so here by using this quantization only, we are going to know how much charge is increased or decreased or transferred from that object. Okay, So the quantization of charge is nothing but the integral multiple of the fundamental charge, which means the multiplication of the fundamental charge. Okay, so the formula is Q, which is equal to NE. So this Q is represents the charge, the fundamental charge. Okay, the Q is represents the charge. Okay, so this E is represents the electrons. This E is represents the electrons. Okay, and this N represents the number of charges which is increasing or decreasing from that object. Okay, number of charges which is increasing or decreasing. So we know that there is some charge which is gaining by this object, correct? So this N will give us the number of charges which is increasing or decreasing while we give the external force in that object. Okay, so this is the number of charges which is increased or decreased in the object when the external force is given. Okay, so this electron will represent the one electron. Okay, so we know that the charge of an electron is 1.6 into 10 power minus 19 coulomb. Okay, so the charge of the electron, the value of the charge of the electron is 1.6 into 10 power minus 19 coulomb. Okay, so if it is the proton means it will have the positive. Okay, so generally we will take this value as plus or minus 1.6 into 10 power minus 19 coulomb. Okay, if in the question they have given us proton means it will have the positive value. So for proton it will have plus 1.6 into 10 power minus 19 coulomb. Okay, for electron it is having, electrons means minus, no, so minus 1.6 into 10 power minus 19 coulomb. Okay, so when we see this N, this N will be the whole number only. So we can get this N value as the whole number only. Maybe the plus or minus 1, the plus or minus 2, the plus or minus 3, etc. Okay, so the N value will be the whole number always. It can't be the fractional number. Okay, it can't be the fractional one, because we know that both the electrons and protons are very, very small objects. We can't cut that. Okay, because they are very, very minute objects, we can't cut that. Okay, so the number of electrons or protons which is present in this object will be in the whole number only. Okay, and also the unit for charge. Do you know the unit for charge? The unit for charge is coulomb. Okay, so that I have given this as C. Okay, coulomb. Okay, and also we know that both the electrons and protons are very minute objects, very small objects. So what is the mass for proton and electron? So the mass for the electron is 9.1 into 10 power minus 31 kg. Okay, so the mass of the proton is 1.6 into 10 power minus 27 kg. Okay, so from this mass value itself you understood that, because both the objects are very, very small and very, very minute objects. See their masses, the masses are very, very small. See their powers. Okay, did you understand? So these are the basic properties, some basic properties of charges. Okay, so first one is it is a scalar quantity, and second one is it is transferable. It can be transferred from one medium to another one medium, or one surface to another surface. Okay, when we apply the external force. Okay, okay Sriniti. Okay, so the charges are conserved, and also it is having, and also the quantization of charge. Okay, so the quantization of charge is nothing but the integral multiple of fundamental charge. So this is the formula for the quantization. So Q will be equal to N into E. Okay, so here this Q is representing the charge which is having the unit of coulomb. Okay, so which is equal to N into E. This E is represents the electron, and this electron, the charge of the electron, we know that plus or minus 1.6 into 10 power minus 19 coulomb. Okay, when we consider the when in the question they have given the proton, means you should use positive 1.6 into 10 power minus 19 coulomb. Okay, whether if they have given electron means you should use negative value. Okay, so the n is nothing but the number of charges which is increased or decreased when we give an external force, okay, external source. So we know that here. So if we want to know how much charges are gained by this comb, by using that formula, okay, we can calculate the number of charges which is gained by that comb by using this formula. Okay, so these are the, and also the number of charges will be always will be the whole number, because we can't cut the proton or electron, because both are the very minute objects. Okay, so we should take this so the n value must be the whole number only. Okay, and also we know that the mass for the electron and proton very lesser mass. Okay, so the mass of the electron is this one, 9.1 into 10 power minus 31 kg, and mass of the proton is this one. Okay, have you all understand up to this, or do you have any doubt? If you have any doubt, tell me in the comment. Otherwise we will move on to the next one. This is the mass of the proton, Sriniti. Here I have right now. So this is the mass of the proton, 1.6 into 10 power minus 27 kg. These are all the universal constant. Okay, you must memorize these values. Okay, you can use these values in the problems. Okay, most of the values will be given in the question itself. Okay, most of the common values will be given in the question itself. Suppose if they are not given, means you should memorize these values. Okay, so this is the mass of the electron, this is the mass for the proton, and this is the charge of an electron. Okay, Haja. Okay, so we will see some problem based on the quantization of charges. Okay, so we have see the quantization formula here, no? So Q, which is equal to N into E, correct? So the number of the polythene piece rubbed with wool is found to have a negative charge of 6 into 10 power minus 7 coulomb. So in the question itself they have representing it's a negative charge. We know that negative charge is negative charge means it is an electron. Okay, so of 6 into 10 power minus 7 coulomb, what is the number of electrons transferred to polythene from wool? Okay, so the polythene piece is rubbed. Here we have taken the comb and hair example. In the question they have given the polythene piece and it is rubbed with the wool. Okay, so there is the presence of negative charge of 6 into 10 power minus 7 coulomb. Negative means we know that, so electrons are transferring in that to that object. So here we are going to find out the number of electrons transferred to the polythene from wool. Okay, so the options also they have given the here. Sriniti, I have already told the WhatsApp number, no? So if you have any queries, means ask in that WhatsApp number. Okay, they will inform you about the class schedule. Okay da? So these are the options they have given. Okay, Sriniti, we know that formula. So if you know how to solve this formula, means how to solve this problem, means do it by yourself and tell me the answer in the comment. Okay, otherwise you can just follow me. WhatsApp number. Okay. So I will write the WhatsApp number again here, note it down. So if you have any queries about the schedule for the class English medium means, you can just interact with this number by WhatsApp only. Okay, just send the message through WhatsApp only. Okay, so this is the number 9566073776. Okay, okay Darshana. So if you have any doubt or queries means, just WhatsApp your queries to this number. They will inform you about the schedule. Okay. Okay, Sriniti. Okay, Darshana. So we know that here number of electrons transferred from wool to polythene. Okay, so that only we are going to find out. No, so number of electrons transferred from this wool to polythene. So number means we know that formula Q, which is equal to Ne. Okay, here they have asking the number of electrons transferred, so N will be equal to Q divided by E. Okay, so N will be equal to Q divided by E. So N, which is equal to, here we know that the charges, how much charges is transferring, 6 into 10 power minus 7 coulomb. So negative, they have already given the negative charge, so minus of 6 into 10 power minus 7 coulomb divided by, we know that what is the charge of an electron, which is 1.6 into 10 power minus 19, correct? Pragalatan, just change your resolution, you can get clear video. Okay, Pragalatan. So here they have given the electrons only transferring. Okay, so we should write the negative sign. Do you know how this negative sign is present here? Because if they have given the number of protons are transferred to the polythene means, you should write the positive. You should take the positive 1.6 video. Okay. Ma, just check your resolution. Okay. Just change your resolution. Check your resolution, might. After that it will clear. Okay. Okay, Sriniti and Haja. Okay, so when we solve this, we can get 3.75 into 10 power 12. Okay, Pragalatan. Okay, so the number of electrons transferred from the, okay, Srinidhi, transferred from the wool to polythene will be the this one. So the answer D is the correct one. Okay, so did you understand? So they have given how much, how numbers of electrons transferred from this polythene, from the wool to polythene. Okay, so we know that formula from the quantization of electrons, we have take this quantization of charges, we have take this formula. Okay, so just substitute the known values here and you can get the answer. Okay, did you understand this problem? Shall we move on to the next one? And also you should very aware of that, if that is the electrons or protons. Okay, so if it is electrons means you should use the negative signs, and if it is the protons means you should use the positive one. Okay, and also in the question itself they have representing it is a negative charge, so I have put the negative sign for the Q value also. Okay, have you all understood this problem? Shall we move on to the next one? So if you have any doubt, just tell me in the comment. I will repeat it once again, okay? Okay, we will move on to the next problem, the same as this one, okay? So the number of electrons that must be removed from an electrically neutral silver dollar to give it a charge of plus 2.4 coulomb. Okay, so in this question they have asking the number of electrons that must be removed from an electrically neutral silver dollar. Neutral in the sense, what is the meaning for that? Both the positive and negative charges are equally distributed in that silver dollar. Okay, so options are also they have given. We know the total charge they have given. So the total charge, okay Pragladan, good. So the total charge is plus 2.4 coulomb. Okay, so the total charge they have given in the question itself, it is 2.4 coulomb. Okay, so the quantization of charge formula is Q equal to N into E. So the number of electrons which is removed from that object, number of electrons which is equal to Q divided by E. So the total charge is 2.4 divided by electrons value. We know that charge of electron is 1.6 into 10 power minus 19 C. Okay, so we will take negative. Okay, but in the question they are representing in the positive only. That is not problem. But in the electrons means you should use the negative sign. Okay, so when we solve this, we can get 1.5 into 10 power 19 electrons. So the answer B is the correct answer. Okay, so okay Pragladan, okay. Okay Haja. So the number of, in this question, the previous question they have asking how number of electrons which is transferred. Okay, but in this question they have asking number of electrons that must be removed. Okay, so the same formula only, but in this question the total charge they have given, correct? So the total charge they have given, so from that we are using this same formula. So we know that charge of an electron, so when we divide these both terms, we get this answer. Okay, so the electrons they have given, the electrons are removed from this object. Okay, so we have put the negative sign, but in the question they didn't consider the negative sign, so just take 1.5 into 10 power 19 as the answer. Okay, have you all understood this problem? So if you have any doubt, tell me in the comment. Okay, shall we move on to the next one? Okay, I will move on to the next topic. So if you have any doubt, just ask me in the comment. I will repeat it once again. Okay, so the next one is Coulomb's law. So consider two charges, which is Q1 and another one is Q2. So both are in the static rest position. Okay, so if we are going to find out the force acting between these two objects, so these two particles are separated by certain distance, we consider here as R. Okay, so consider two charges, both are in the maybe the same charges or maybe the opposite charges. Okay, so if both the charges are same charge means what will happen? They will repulse each other. Okay, if it is opposite charge means what will happen? They attract each other. Okay, so this is the basic concept of Coulomb. Okay, so if same charges means same charge repulse each other and the opposite charge attract each other. Okay, so consider two charges, which is Q1 and Q2. It may be the same charge or it may be the variable opposite charges. Okay, so they have separated with a certain distance r. Okay, so if we are going to find the force acting between these two charge, means we are using the, for that we are using the Coulomb's law. Okay, so that Coulomb's law represents the F is directly proportional to the product of the two charges present here. Okay, so the F is directly proportional to product of the two charges. Here the charges are q1 and q2. Okay, so the product in the self q1 into q2. Okay, and also this F is directly inversely proportional to the square of the distance between the charges. Okay, so this F is directly proportional from the Coulomb's law. The Coulomb's law states that the force which is acting on these two particles will be directly proportional to the product of the two charges, and also it is the inversely proportional to the square of the distance between these two charges. Okay, so F is directly proportional to q1 q2 divided by r square. Okay, so F is directly proportional to q1 q2 divided by r square. Okay, so consider both are having the positive. Okay, consider we have already considered q1 and q2, so consider both are having the positive. Praklathan, are you from Tamil medium? So this class is for English medium Praklathans. Okay, so if you can't understand means just tell me. Okay, okay Praklathan, okay. Okay, I will try to teach in both language. Okay, Pragalatan? So consider these both charges are having the same charge. Okay, positive and positive. What will happen? They will repel each other. Correct. So they will repel each other. So the distance between the both charges will be the r. Okay, so the distance between these two charges will repulse each other because both the charges having the same charge. Okay, so consider this will having the F1 force and this will have the F2 force. Okay, because we have considered this point as 1 and this is 2, so this will have the F1 and this will have the F2. So the direction will be the in this direction. Okay, so both are will be the repulsion. Okay, so this will take the direction in this. Okay, so if we write the force acting between these two objects, so the force acting on this F12 represents previously. Dashna, those questions are from the previous year NEET questions. Okay. Okay, Sriniti. Okay, I will try to teach in both language. Okay, Sriniti. Okay, okay, ma. So we have considered two charges, both are same charges. Okay, so what will happen, these both charges will repel each other. Okay, so this will have the F1 force and this will have the F2 force. Okay, because we have considered this as the particle 1 and this as the particle 2, so this will be the F1 and this will be the F2. Okay, so this F12 represents the force which is acting on 1 by the 2. Okay, so this F12 represents the force which is acting on the particle 1 by the 2. Okay, Okay, Praglatan, okay. Okay, Srinidhi. Okay, same as here it will have F21, okay, because both the charges, this F21 is nothing but the charge which is happened because of this F1, okay. So we know that it is separating by the distance r. So if we write the distance between them, we can take the distance r12 vector, okay. So if we take the distance between the two charges means r12 vector, because here 2 is present here, so the 1 will be, the direction is, we have taken the direction in this direction, so distance is from this point to this point, so we have taken 1 to 2, okay. Did you understand? So we can also write this r12 as r12 cap r12 modulus, okay. So this is the unit vector, we know that this is the unit vector. So the unit vector value is 1, okay. So first I have considered the distance for this object, okay. So when we have the distance between these two objects, so when we have for F2 means the object will travel from here to here, so it will be F12, okay. At the same, when we consider F12, the object will travel from here to here, so the distance will be the R21. Okay, so when we write in terms of this one, we can get minus r21 vector. Okay, when you take this r21 in the form of r12 means it will have the minus r21, okay, because r12 means it will have the displacement from here to here, r21 means it will have the displacement from here to here, okay. So it will have the opposite sign. Did you understand? Yes, Darshana, some questions will be in your book also, okay. Mostly NEET based previous year questions will be discussed in our class, okay, Darshana. Did you understand? So when we have considered this F21 force, the distance will be the r21, because the charges traveled from here to here, okay. So when we consider this one, the particle will be travel here to here, so it will have r21. So when we take in terms of r12 means it will have the negative sign, okay. So we will substitute here this component in the formula. So F21 vector is directly proportional to q1 q2 divided by r squared, okay. So and also it will have the unit vector r21 cap, okay. So the unit vector value is 1 only, okay. So when we write, if you want to remove, in order to remove this proportionality constant, okay. Okay, Srinidhi, just I already told the WhatsApp number, no? Just contact with that WhatsApp number, okay? So F21 is directly proportional to, we have already know that F21 vector is already directly proportional to q1 q2 divided by r squared, and also it is having the unit vector r12 cap, okay. So F21, in order to remove this proportionality constant, we are going to include the, okay, oh, okay, Srinidhi, okay. Okay, so this is the proportionality constant K, q1 q2 divided by r squared, so r12 cap, okay. So we know that, so the F is directly proportional by Coulomb's law, the F is directly proportional to the products of the two charges, and also it is inversely proportional to the square of the distance between those two charges. Okay, so in order to remove this proportionality constant, we have to include this k. Okay, so the value for k is 9 into 10 power 9 n m squared. Okay, Darshana, just contact with WhatsApp number. With that WhatsApp number, they will tell you. Okay, what is the procedure for that? Okay, they will tell you. So the value for k is 9 into 10 power 9 n m squared c power minus 2. Okay, so the value for k is 9 into 10 power 9 n m squared c power minus 2. Okay, so the k is 1.4 pi epsilon naught. Okay, so this epsilon naught is nothing but permittivity of free space. Okay, so this epsilon naught is nothing but permittivity of free space. Okay, so the epsilon naught value is, it is the permittivity of free space. So it will take the value, it is having the value 8.85 into 10 power minus 12 c squared n power minus 1 m power minus 2. Okay, so we have included the proportionality constant in order to remove this proportional. Okay, so the value for this k is 9 into 10 power 9 n m squared c power minus 2. Okay, so the k value is 1 by 4 pi epsilon naught. The epsilon naught is nothing but the permittivity of free space. Okay, so it is also having the value which is 8.85 into 10 power minus 12 c squared n power minus 1 m power minus 2. Okay, so the permittivity also, the formula for permittivity is, relative permittivity is epsilon r, which is equal to epsilon divided by epsilon naught, which is equal to 1. Okay, so if we consider the air medium, air or vacuum medium means the epsilon r will be equal to 1. Okay, if we consider any other medium, if we consider for example insulators, dielectrics means it will have the more than 1. Okay, so the relative permittivity formula is epsilon divided by epsilon naught, which is equal to 1. Okay, so if we are taking the air medium or vacuum means it is having the 1. Okay, so if we are considering, if we are taking any other medium, for example if we are taking insulators or dielectrics means it will be greater than, the epsilon r will be greater than 1. Okay, we will see this epsilon and epsilon r concept in dielectric topic. Okay, so we know that this is our formula by the Coulomb's law. Okay, so if I consider the distance between the two charges is 1 and also the charges the q1 q2 also the 1 coulomb means the f value will be equal to 9 into 10 power 9 Newton. Okay, so if I consider the distance between the particles is 1 meter and also the q1 which is equal to q2 which is equal to 1 coulomb means the force acting here by the Coulomb's law is 9 into 10 power 9 Newton. Okay, have you all understood? Shall we move on to the next one? If you have any doubt, just tell me in the comment. Okay, Pooja, okay. Okay, Haja, Pooja, okay. Okay, so this is the problem based on the Coulomb's law formula. Okay, so very simple problem. The force between two small charged spheres having charges of 1 into 10 power minus 7 coulomb and 2 into 10 power minus 7 coulomb placed 20 centimeter apart in air is. So the options also they have given. So we know the formula. What is the formula for force from Coulomb's law? So F is equal to Q1 Q2 divided by 4 pi epsilon naught R squared. Okay, so instead of K I have used, so instead of this K I have used 1 by 4 pi epsilon naught. Both are same only. Okay, so F which is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R squared. This one and this one both are equal only. Okay, so the value for this 1 by 4 pi epsilon naught is 9 into 10 power 9. Okay, and what are the values given in the question? Q1 will be 1 into 10 power minus 7c and Q2 is the 2 into 10 power minus 7 coulomb. Okay, so consider this as the Q1 and consider this as the Q2. Okay, both are placed up 20 centimeter apart. Okay, then the distance between the both part charges are 20 centimeter. Okay, so here the distance they have given in the unit of centimeter. So in order to convert this into the meter, I am going to multiply it with 10 power minus 2 meter. Okay, so in order to convert this centimeter into the meter, I just multiply it with the 10 power minus 2. So just substitute the known values here. So F will be equal to 9 into 10 power 9 into Q1 is 1 into 10 power minus 7. Q2 is 2 into 10 power minus 7. Okay, so divided by R squared value is 20 into 10 power minus 2 the whole square. Okay, so the R2 value is this one. Okay, so listen this carefully. So 1 by 4 pi epsilon naught value is 9 into 10 power 9. Okay, so you should write 9 into 10 power 9. Okay, here the 4 pi epsilon naught is in denominator, so you should not write 1 by 9 into 10 power 9. This is wrong. So the whole term, the whole 1 by 4 pi epsilon naught value is 9 into 10 power 9. Okay, so just clear about that. Okay, so don't confuse yourself. If you are taking K means it is 9 into 10 power 9. Okay, so when you solve this, you can get 4.5 into 10 power minus 3 Newton. So option B is the correct answer. Okay, so try to solve these mathematical calculation by yourself. So this is the answer for this question. Okay, have you all understood? This is very direct question only. So they have asking the force between the two charged spheres, and also they have given the charges also. Okay, so just we have substitute the given charges in the question and we can get the force value as 4.5 into 10 power minus 3 Newton. Have you all understood this problem, or do you have any doubt? If you have any doubt, tell me in the comment. I will repeat it once again. Okay ma, okay, so the class is over today. Okay, so the session is over today. If you have any doubt, ask me in the comment. I will reply about this topic. Okay, if you have any doubt regarding class schedule means just WhatsApp to that number. They will inform you about schedule. Okay, which step, Manju? Second step. See here, Manju, we know the formula F equal to Q1 into Q2 divided by 4 pi epsilon naught R square. Okay, so here we know the value for 1 by 4 pi epsilon naught is 9 into 10 power 9. So I have substituted 9 into 10 power 9 for 1 by 4 pi epsilon naught. Okay, so for Q1 and Q2 they have given. Correct. So for Q1 and Q2 they have given in the question itself. So just substitute the values. For R squared, the distance they have given 20 into 10 power 20, they have given 20 centimeter. So we have to converted it into the meter. So I just multiply it with 10 power minus 2 meter. Okay, so we can get, when you after this you will have only simple mathematical. So when you solve this, you can get the answer 4.5 into 10 power minus 3 Newton. So option B is the correct answer. Okay Manju? Okay ma, so the class is over today. So we will see the remaining topics in the next class. Okay, if you have any doubts, still tell me in the comment. I will reteach in the next class. Okay, okay Manju. Okay, okay, thank you ma. Okay Manju.